Okay, so we're going to spend 3 days on special ways to integrate by this method called substitution. And then the rest of the chapter is just different ways of integrating things that you have not seen before. And then at the end of the chapter, we're going to tie it back into all the stuff that you have learned. So, these kind of word problems, but you have to integrate by these methods. Okay, so integration by substitution is just a tool. If you can't integrate by some other method, then do it. A lot of people, when I learned in high school, our teacher did not teach us substitution. He says, just guess. And we learned by guessing, and we guessed really well. But if, this is a method that will work for many, many, many things. So that's why I'm teaching you this as a tool. Okay, so for example, this one. So go ahead and copy this down first. Okay, so this question, if you were to integrate, it might be a little bit daunting because there's so many parts to it. So what you want to do is this method by substitution where you identify the most complicated part of this problem. So the most complicated function of this problem. So for this problem, what you would do is probably here, right? This is probably really complicated, right? So what we're going to do is we're going to take this part inside. And then we're going to call that u. 1 plus x squared. So I'm going to do a substitution into changing all the x's into u's. So first I identify the most complicated part, and then I'm going to call it u. Then I'm going to take the derivative of u with respect to x. So what is the derivative of u? 2x. Okay, 2x, and then I want to write dx. 2x dx. Then what I'm going to do is I'm going to look back on here and say, can I just substitute directly in? Okay, so for example, 1 plus x squared is u, right? So I have a direct translation. 2x dx is this part. 2x dx is du. Can you guys see that? So this problem becomes square root u du. So now the problem is very easy to solve. Okay, if you cannot see it, please let me know. Okay, so I take the most complicated part and then I make it into u. Then I take the derivative, I get du, so left-hand side, right-hand side is a 2x dx. Then I try to do a comparison and I say, okay, u is 1 plus x squared, this part's going to be u. This part is 2x dx, that's 2x dx, that whole thing becomes du. So then this is the new problem. Okay, now it's easy to integrate, right? It's just square root u. So, all right, what's a good guess for square root u, the integral? 3 over 2. All right, so then we're going to integrate, take the derivative to double check. 3/2 u to the 1/2. 2 over 3. So I don't want that 3/2 in the front, so I'm going to multiply by 2 over 3. So this becomes 2/3 u to the 3 over 2.
Plus c.
Thank you. Yes, plus c. All the indefinite integrals have plus c. Please don't forget that. The last thing you're going to do is substitute back. 2/3, and then I know that u is 1 plus x squared. So 1 plus x squared to the 3/2 plus c. Yes. So you got to identify the parts. So find the most complicated part, write it as u, take the derivative, and then try to put everything back. Yes?
Why don't they teach us shortcuts like these at the beginning of the chapter?
Because you have other things you have to learn at a time. Okay, anyways, let's go on to the next practice. Okay, so let's have you copy this down first. This is a slightly harder example, just a little bit. Okay, so identify the complicated part. Yes, e to the x cubed is pretty complicated, and this is kind of the tricky thing. So like the previous example, you have a square root with something inside, right? We almost never take the square root as the complicated part. We never take the e as the complicated part. We just take this part. Reason being, if you do try to make u e to the x cubed, du is going to have another e, and then you won't be able to solve it. Okay? Yes, you have a question.
So is it u to the, or e to the u?
No, we're just going to make u the x cubed. Eventually, yes. Okay, now what is du?
X squared dx.
3x squared dx. Yes. Now, if you make a comparison back, x cubed is u, so that becomes e to the u. That's pretty good. I have a 3x squared here, dx. I don't have a 3. I have to make a 3, or I need to make it match, right? So it doesn't match right now. X squared dx. I just want this part.
You divide by
Yes, I divide by 3. So this becomes 1/3 du is x squared dx. Whatever constant I don't want, I divide it out on both sides of dx and du so that when I plug it back in, it matches exactly. Are you guys with me? This is the complicated part. Okay, so this becomes integral. All right, this is a little tricky. Okay, e to the u. You guys are okay with that, right?
Yeah.
Okay, and then 1/3 du. Yes?
Yep.
Okay, when you integrate, you almost never want to leave constants inside. It's very complicated to integrate. Take the 1/3 out and then integrate. What is the integral of e to the u? Go, yes. So it's 1/3 e to the u plus c, and then we got to substitute back. 1/3 e to the x cubed plus c. Okay, so far? Okay, let's try one more. This one. All right, again, we don't want to take the part that has like e or square root, that kind of stuff along with it. We just want to take the x part as the complicated part. So which part should be u?
X to the fourth plus 2.
Yes, x to the 4th plus 2. Okay, then what is du?
4x
Dx. All right, so again, make a comparison and ask yourself, how do I make them match? This part's going to be u. I just need an x cubed dx. I don't need this 4. So what should I do? Divide by 4. Yes, so 1/4 du is x cubed dx. Okay, now I can make a direct substitution. So go ahead and solve this one. Answer is 1/4 sine x to the 4th plus 2 plus c. A lot of you have a negative. Please be careful. There's no negative. The derivative of sine is just cosine. The derivative of cosine is negative sine. Okay. All right, next one. This one you can do on your own. Okay, so the hardest part is going to be this part, 2x plus 1. So 2x plus 1, and du is 2 dx. So I don't want the 2. I'm going to divide by 2. So 1/2 du is dx. So this becomes, I'm going to just always put the constant outside or the coefficient outside. So 1/2 integral of square root u du. All right, the guess of square root u is going to be u to the 3/2. So this becomes 3/2 u to the 1/2. I don't want the 3/2, so I'm going to multiply by 2/3. So this becomes 1/2 times 2/3, and then u to the 3/2 plus c. Okay, so this becomes 1/3 2x plus 1 to the 3/2 plus c. Yes?
Could
Could you do it like normally without the
Yes, you could just guess.
Can you like show it?
Right, so square root of 2x plus 1 dx. Like, what would you do to guess what the integral would be? I would guess it's going to be 2x plus 1 to the 3/2, right?
Yeah.
So then, because the integral of a square root is going to be 1 power higher, so 3/2. So take the integral, take the derivative. 3/2 times 2x plus 1 to the 1/2, chain rule times 2. That's going to give me just 3 times 2x plus 1 to the 1/2. I don't want that 3 at all, so I'm going to multiply this by 1/3. So then this is the answer, plus c. So this is the way I did it in high school, but you have to just be able to see the part and integrate, which is totally fine. You don't need u du. However, you need to know how to do it because on the test, they're going to ask you which part do you think u is? Or if I make this u, then what do you think this part is? So they expect that you already know how to do it. Even though if you want to do something else, you could. Yeah.
And we can use this on the test if we want.
Yeah, of course. It's just that if I ask you a du question, you need to know how to do it as well. Yes.
Can you use it like to solve the simplest problems?
Yeah, you can. Yeah, you can. All right, let's do a few more examples. This one. Okay, the answer is -1/4, 1 minus 4x squared to the 1/2 plus c. All right. Okay, so let's try a few more. The next one is not too hard. You just have to figure out which part is u. You guys almost done copying? Almost. All right, this one. The answer is -e to the cosine t plus c. All right, we're going to try one where you have a ton of variables with no numbers. So notice this problem. It says dx. dx means only x is variable. That means a and b are both just constants. Okay, treat them like numbers. Yeah, I don't know why they're 2dx.
Oh, okay.
The answer is 1 over a natural log a plus x plus b plus c.
Oh.